Hi guys, it's good to be back. I'm seeing you after 1.5 weeks now. In fact, the webinar scheduling has been a little erratic in the last 2 weeks. I did come on time from my Delhi travels, but the moment I landed, my throat clogged up. That is why I just couldn't even speak. In fact, my family seems to think it's because, my system is rejecting the clean Pune air and it's gotten used to the pollution of Delhi. So I think it's going to take some time to get used to the clean air now, but then we might as well continue with our webinars, right? How long are we going to wait? In fact, the next webinar is also going to be on a Tuesday and not on a Wednesday. And I'm sure that many of you are rather happy about it because many of you certainly do plan to ditch GMAT next Wednesday because of the India's World Cup match, right? So, and I'm sure I'm going to be a little distracted as well. So, we might as well study properly on Tuesday and then enjoy the match on Wednesday as well as on Thursday. So today we are going to look at some number properties questions, some factors and factorization. Now these are all questions which are 700 plus level, and people on GMAT Club found them hard. So they're all inspired from those questions only. And we'll see how from the videos and the module, the concepts that we have learned over there are going to help us solve these questions within a minute. Yeah. I'll discuss what my thought process is when I look at these questions and what is given to me in these questions, and how we can relate it to the concepts that we have discussed in the module and in the videos, right? And once we do that, then it doesn't take more than a minute to solve any of these questions, even though they are slightly tricky and people do find them hard. Okay. So then let me share my screen. Okay, let's take a look at it together now. Given that n is a perfect square, we just discussed what a perfect square is, right? In the previous question, we discussed what a perfect cube is and what should come to our mind when we read perfect cube and what should come to our mind when we read perfect square. So, what should come to our mind when we read perfect square? When I say n is a perfect square, it means that the exponents in its prime factorization are all going to be even, right? So, if I can write, let's say, let me write this as this is the prime factorization of n into c to the power z. Then this is the prime factorization. What does prime factorization mean? It means that n is divided into its prime factors. All the similar, the identical prime factors are clubbed together. So let's say if n has 2 into 2 into 3 into 5, for example, then these two are going to be clubbed together. We'll have 2 square into 3 into 5. This is the prime factorization of n, right? So when I prime factorize n, then x, y, and z all should be even when my n is a perfect square, right? Okay, so I'm given that n is a perfect square and n is equal to this. It is equal to a to the power x into b to the power y into c to the power z, where a, b, and c are all prime integers. So these are all primes as well, all right? Are a, b, and c all distinct? Now, note here that we are not given that this is the prime factorization of n. We are not given that. We only given that n can be represented as a to the power x into b to the power y into c to the power z. We know that a, b, and c are all prime integers, so that is great. But we are not given that a, b, and c are all distinct. Look, in a prime factorization, all of these need to be distinct, right? It is based on a concept that we do discuss quite often, and we read through in our module and in the video as well. But then it's something that we don't really focus on as such, right? But then it is understood that in a prime factorization, each term, each base has to be distinct. Yeah, because we are clubbing all the identical bases together. So basically, we're clubbing the two twos together. Then we get the prime factorization, right? All right. So now over here in this expression, I can represent n as this, but the point is that are A, B, and C all distinct? All right. Now, for example, let me look at the prime factorization of a perfect square. Let's say this is a perfect square, and it is a perfect square, and this is a prime factorization of a perfect square. When my 2, 3, and 5 are all distinct, of course, the exponents are all even. But then, what if I write this as this? note that this is still a perfect square. But my exponents are not all even now. Why? Because these two are identical, because these two bases are not distinct, right? So then it is possible to have odd exponents if the bases are not distinct. We have to ensure that the bases are distinct, and if they are, then the exponents will always be even in case of a perfect square. All right. So I hope we understand this, what a perfect square is and how it is represented, right? Now, we are asked whether are A, B, and C all distinct, right? All right. Now, statement 1 says 6 is a factor of x, y, z. So it says that when we multiply all these exponents together, the x, y, and z given to us, when we multiply all of them, then one of the factors of this is 6. What does that tell us? Well, it doesn't tell us anything, right? We don't know whether x, y, and z are all even or not. Well, they could be all even, they could be at least one of them is even for sure, because there is a 2 over here. 6 is 2 into 3, right? So at least there is 1, 2. So I know that at least one of them is even. But then is that enough to tell me whether all of them are even or not, or whether one of them is odd? Because if one of them is odd, then I know for sure that A, B, and C are not all distinct, right? Because if A, B, and C are distinct, then all of them have to be even for sure, right? So then, uh, 6 being a factor of XYZ doesn't really tell me anything. So then the statement alone is not sufficient. So let me just ignore it and I'll forget the information that is over there. I'll go on to my statement 2. 8 is not a factor of X, Y, Z. What does this tell me? When I say 8 is not a factor, it means there are not, in this product of XYZ, I do not have 3 twos. I could have 2 twos, I could have a 2, or I may have no 2, whatever. But in the product, I do not have 3 twos, which means that all 3 of them are not even for sure. Yeah, there is at least one of them which is not even. Why? Because if all 3 of them were even, each one of them would have had a 2, and then the product would have been divisible by 8 for sure. So now from statement 2, there is one thing I can say, that all exponents are not even. There is at least one which is not even, which is odd. Now, if all exponents are not even, but n is a perfect square, I'm given that it is a perfect square. What does that mean? It means that the situation is something like this. It means that A, B, and C are not all distinct. There are at least two of them that are same, that are equal to each other. And that is why this statement alone is sufficient. Yeah. So our answer over here is going to be B. Now, there was a question which asked that if we were given that 8 is the factor of x, y, z, then would that mean that A, B, and C are all distinct? Think about it. No, that is not correct. If 8 is a factor, first of all, if 8 is a factor of x, y, z, doesn't mean that the three twos have arrived from each from x, one from y, and one from z, as in, is that true? It is possible that the entire 8 came from x and y and z are odd, isn't it? So then 8 being a factor of x, y, z does not tell me that each one of them is even, that x, y, z, each one of them is even. All right, even if I assume that each one of them is even then, can I say that A, B, and C are all distinct? Think about this now. I could also write n as, let's say, 2 square into 2 to the power 4 into 3 square into, let's say, 5 to the power 4. This is also possible, right? This is also a perfect square. I can write n as this, right? Every exponent is even over here. It is a perfect square, but does it mean that each base is distinct? Well, it's not necessary, isn't it? It is possible that the bases are same. So even if I knew that each one of x, y, and z is even then I cannot say that A, B, and C are distinct. Look, nothing in the statement tells me that this is the prime factorization, right? It is just a way in which I can express n. Yeah, it's just a way in which I can express n. All right. Okay. So this was it. Now we'll move on to the next.